Um, all right, well then we'll go ahead and get started. Well, good afternoon, everyone. Thanks to everyone who's joined today for the August edition of the West Watch. We're going to jump right in as we're just a minute or two behind. Again, welcome everyone, and hopefully we have some new folks on. And if we do have some new folks, I'll give a quick overview of what the West Watch is. So this is now a monthly webinar series that brings together primarily NOAA staff. We have a lot of partners from academia and other regional agencies to discuss climate and observations and oceanic impacts all across the West. We do have been doing two formats. The format today is the format with climate updates from myself and oceanic and coastal updates from our IUS partners, and then we alternate every other month where we have a topic-specific webinar that will happen perhaps after this one, such as heat waves or atmospheric rivers or that sort of topic-specific webinar. A few things before we get started with housekeeping. If you do have questions, we hope to have time to answer those questions at the end. There is a question box. It should be at the right-hand side of your screen, and you can enter questions there or raise your hand at the end. Again, we should have time for Q&A at the end. These will be recorded and posted on the website with the recording for future viewing, and you should receive a post-webinar survey, and we always greatly appreciate the feedback on that. And I also did want to mention, so Joe Casola used to be the one to lead this webinar series, and he is no longer the Regional Climate Services Director for NOAA in the West region. He has taken a new job with the USGS as the Regional Senior Scientist in the Rocky Mountain region. And so I just want to give a big thanks to Joe, who ran these for so long, and wish him luck at his new position. But we will move forward with the West Watch series as long as we can, and hopefully continue this. So today I'm going to present the climate update, and then we'll have our IUS partners, Clarissa Anderson, Henry Ruhl, and Jan Newton. And so I'm going to go ahead and jump in here with the climate update and outlook. And so I wanted to start off with some maps showing what the temperatures have been like this summer across the Western United States. And as the heading says there, the heat is on for sure. Of course, summer is always the hottest time of year, but temperatures have been above normal for most places in the West across for the better part of the summer. So on the left, we have the June monthly mean temperature departures from normal. In the middle is July, and then on the right is August 1st through the 16th with some of the most recent daily data.
Dan, I don't think we're seeing your slides. Sorry to interrupt.
Oh, no, it's all right. Are you seeing anything?
We're just seeing you. I thought it was me.
That's not good. Let's see here. Oh, okay. What's going on here? Change presenter, me, show my screen. Okay, is it back?
Yes, that's great.
Okay, thank you for letting me know. Apologies for the technical difficulties there. So we're back here. Hopefully it'll stay like this. So again, I want to discuss the summer heat so far across the Western US, with June on the left, July in the middle, and then August through about half of the month on the right. You'll notice there's a lot more reds than blues here on this map, indicating above normal temperatures. So with June, most of the West was above normal, except for kind of the northern tier in Washington, northern Idaho, and Montana. And then July was extremely hot for most of the West Coast, California, Nevada, Oregon, Washington. And then there's been a continuation into August with the heat, although there has been some cooling over the last week, and that may continue to bring some relief. And in terms of ranking, temperature ranking, so this map is showing all these little flags are the long-term weather stations, and these are showing the rankings from highest to lowest for July temperatures. And any of those dark red flags with the number 1 indicate July was the hottest July on record for that particular location. And there were a whole lot of Western US cities that set new records for July, including Reno and Las Vegas in Nevada, Sacramento, Fresno, Bakersfield, and Death Valley in California, Portland, Salem, and Eugene in Oregon. And there were many others, but those were some of the major cities that stood out. And so I mentioned Death Valley. So Death Valley had its warmest, not only its warmest July on record, but its warmest month in its entire historical period. We would expect that to be in the summer, probably July or August. And so this is a snapshot from a news release from the National Park Service where they have a little story about the temperatures and some of the impacts. But for example, the mean temperature for the month was 108.5. The highest daily maximum was 129, and the mean minimum temperatures really stands out of 95.2. So the nights just don't cool off. And Death Valley is a hot place, but this was an exceptionally hot July for the region and for Death Valley. And another place that really stood out with kind of exceptional numbers for temperatures was Las Vegas. This is an infographic from the National Weather Service Vegas Twitter feed, and so they're showing kind of some summary of their numbers here, and a few things that stood out. The average temperature was 6.7 degrees above normal, which is a very large anomaly for a monthly mean, and their warmest daily max of the month was 120 degrees, which occurred on July 7th. And so if we look at their previous highest temperature on record, it was 117 degrees, which happened in 2021 and a few other times. And so this year they hit 120, which shattered that record by 3 degrees, and also hit 118 twice and 119 once, just showing how intense the heat waves were that were impacting Las Vegas. And the nighttime lows, again, 4 times in a row, a total of 5 times. The minimum was 94 degrees, which is the second highest minimum temperature, so just extremely warm for this region. So we can talk a little bit about precipitation now for the month. On the left, sorry, not the month, kind of going back to early summer. So on the left is July 1st through August 16th, the percent of normal precipitation, so the anomaly, with the browns being drier and greens being wetter than average. And then with summer precipitation maps in the west, I always like to give some context. And so on the right is the July 1st through August 16th average precipitation that we typically get. And a few things to point out. Most of California, the average for that time period is pretty close, darn close to 0. And so when you see those anomalies on the left, they're not all that meaningful if your average is near 0. The northern Great Basin and northeast Great Basin is also very dry. Anything in that lightest shade there is less than 1/2 inch on average for that month-and-a-half period. But there are other places that do get impactful precipitation during the summer months, especially the monsoon region, and the core states in the monsoon region are really Arizona and New Mexico, although that moisture does expand northward and a bit westward, but that's kind of the core region. And then the northern tier, the higher elevations in Washington, Idaho, Montana also get beneficial summer precipitation. And so then if we look back at the anomaly map in those kind of impactful regions, we see a lot of browns in the monsoon region with some isolated areas of above normal precipitation. The monsoon rain is typically convective and thunderstorms, so it's much more isolated than sort of cold frontal precipitation, but a lot of below normals, and also quite dry in the Pacific Northwest in Washington and parts of Montana, but parts of Northwest Montana also had some above normal precipitation. And this is a graphic from the University of Arizona's monsoon tracker. And what this is showing is the percent of the Southwest in each of the precipitation categories. And so their definition of the Southwest is Arizona and New Mexico for the monsoon region. And so, the technical date for the start of monsoon season is June 15th, going through the end of September. And so this is showing the time series of how much of that area was in below average, above average, much above average as you went through the monsoon season. If you go all the way to the right of the graphic, that is from August 18th, we see that about 40% of the area is in a below average category for precipitation, and just 20% of that area is above. And really the biggest category is that near average between 75 and 125% of average. So it's really a mixed bag depending on where you are, but a lot of areas in the monsoon region are below average for the year. And that kind of leads into the current drought conditions. So on the left is the latest US Drought Monitor map that was released last Thursday. Any of the yellows are abnormally dry, but not drought categories. And then the other colors are increasing drought severity from moderate to exceptional drought. Most of California and Nevada, and most of Utah and Arizona are mostly drought-free with some small areas. Really the biggest areas of drought coverage right now are western Montana into northern Idaho and parts of Washington and Oregon, and also that persistent drought in southern New Mexico that has really persisted for a while now. And then on the right shows how the drought classes have changed over the past 2 months or so. And what we can see is that there's been a lot of added or expanded drought conditions in Oregon, Washington, Idaho, extending into California, with some drought relief in other places, thanks to some of that monsoon precipitation in New Mexico and parts of Colorado. In terms of a quick wildfire update, we are in the middle of the wildfire season in the Western US during the peak of that dry season, as I showed you some context with the precipitation climatology map that tends to align with drier fuels and much easier to start and spread wildfires and warmer temperatures, of course. And so all these little fire icons are active wildfires as of yesterday. And so there are a number of active fires burning in the West, an awful lot burning in Canada as well, bringing really smoke and poor air quality to much of the United States due to all the fire activity. And these statistics here are from NIFC, the National Interagency Fire Center, that compile these. And so if we look at how this year is comparing to past years, right now there's been a little over 30,000 fires, and about 5.4 million acres have burned. And if you can compare that to the 10-year average to date, we are above average for acres burned, but below average for the number of fires, indicating that some of these fires are very large in size. Much more acreage than last year to date so far. So a very active wildfire season so far, and there's quite a bit more to come still for some places. And I think another thing with the wildfire season to understand are these preparedness levels. And so as of July, this was the last update I saw was as of July 18th, the national preparedness level is 5, which is as high as that can go. And what that really means is firefighting resources are basically fully, maxed out. And if there are new large fires that start, it makes it more challenging to move resources around. And so in terms of firefighting resources, this is the maximum you can go on that scale nationally. And that's where we're at right now. And there's potential for ongoing fires that will be harder to get resources to with all the other fires currently burning. In terms of the outlook for the month of September, any of these areas in red indicate an above normal chance for significant wildfires. We don't see any green or below normal probability. And so pretty much on that map where a lot of the fires were already burning, there's likely still chances for more continued large fires as we go into September, and the ones that are burning may continue to burn for a while if they aren't able to get contained. So I want to move into the ENSO update. This last update from the Climate Prediction Center was posted on August 12th, and so we're currently in a La Nina watch. ENSO neutral conditions are being observed right now. So the El Nino that we saw last year into the spring has diminished, and that has transitioned into ENSO neutral conditions. And if we look at the map on the right with the sea surface temperature anomalies, we don't see a lot of strong shading, either blues or yellows or oranges. There's a lot of white, and there are some blues starting to show up. So this indicates, near normal ocean conditions there, which is associated with the ENSO neutral category. With that being said, the Climate Prediction Center is forecasting La Nina to emerge during fall, 66% chance, and persist through the winter, 75% chance of that persisting from November through January. And if we look at kind of the different regions in the Nino region and look at the trend over the last year or so, we saw the El Nino peak around December or January, and since then most of the Nino region has been cooling. Nino 3.4, that's the one most commonly used to define El Nino, is right at 0 in that neutral range, and the eastern part of the basin has dropped to below normal, the Nino 1+2. So transitioning from neutral, and if we look at the forecast, it is looking likely that La Nina will return. And so these, again, are from the Climate Prediction Center. On the left, the bar plots there show the probability of being in La Nina, El Nino, or ENSO neutral conditions. And so the first season here, July, August, September, is still likely to stay in ENSO neutral. And then as we shift really in September, October, November, and onward into the winter, the probabilities of heading into a La Nina increase a lot. And by late fall and winter, there's over a 70% chance of a La Nina event. And then on the right is the plumes from all the different models that show the magnitude of this potential event. And so that most of the models do still show La Nina developing. I will say the magnitude of the event does look a little bit weaker than a month or two ago when some of the initial forecasts were released. So we'll have to stay tuned and see how this potential La Nina develops. Then onto the seasonal outlook. And so this was released August 15th, and this is the September, October, November temperature outlook on the left and precipitation outlook on the right. For temperatures, nearly all of the West is expected to have above normal temperatures, with the highest probability is that in the Four Corners region in the monsoon area there, with lesser chances as you get close to the coast, and actually equal chances of above or below normal temperatures for the coastal areas in California and Oregon, and much of Washington state as well. For precipitation, this is already starting to look like a kind of typical La Nina outlook pattern, with drier than normal conditions more likely in the Southwest, and some wetter than normal conditions starting to show up in parts of the Pacific Northwest. And lastly, in terms of the very near term, over the next several days, a lot of the West might see some relief from all that summer heat that I was showing earlier. There's a pretty strong low pressure center and cold front associated with that will be impacting the West Coast. On the left is the 500 millibar height anomaly, and so that's the upper atmospheric pattern showing the low pressure with standard deviations over three standard deviations below normal. So this is a very cold low for this time of year. And then on the bottom left are the temperature anomalies at the surface, anywhere from 10 to 20 degrees below normal. This will be fairly quick, Friday into Saturday. And the graphic on the right is from the National Weather Service in Reno. that indicates even potential for the first snowflakes to fall in the high elevations of the Sierra Nevada, which is a bit early, but not unheard of to have snowfall in the Sierra in August. So I don't know about everyone else, but I'm looking forward to some cool weather, so I will enjoy this when it arrives this weekend. And that is all I had, and now we'll move on to our coastal updates, and I will pass this on to Clarissa to start. And stop showing screen, and try that. Okay.
All right. Good?
Yes. You're good.
Okay. Hi, everyone. I'm Clarissa Anderson, and I'm coming to you from San Diego, SCCOOS, and we're at Scripps. And as in the past, I'll be passing this to Jim Behrens right after me to talk a bit more about the wave activity and climatology from the CDIP perspective. So moving into some of the interesting current events happening in the ocean, you've no doubt heard a lot about the toxic algal bloom that's happening right now. As in summers past on this webinar, we've been covering these domoic acid events more than usual. This is the third really large event in a row in terms of every summer now. We've seen something along the lines of a major marine mammal stranding event focused on California sea lions, focused really in the central coast. So we're talking San Luis Obispo to Santa Barbara, but that's not the only footprint. It has extended all the way to San Diego in terms of some of the strandings that we're seeing, with some of the rescue centers in Los Angeles and Orange County being hit pretty hard. And it is not yet the size of last year's, which was pretty epic, but it's getting there, and it has been growing, and we don't see a huge kind of turning point at this point. But what we are seeing are some other things happen, like shellfish advisories, meaning that the toxins are now getting into the shellfish, or at least accumulating to a point where the California Department of Public Health has to issue an advisory. For recreational harvest, they do monitor the commercial fishery quite well on a weekly basis. One of the kind of hallmarks, I would say, of these blooms that we've had in recent years is that the organism that causes the bloom is really focused on offshore waters. So our nearshore monitoring is not picking it up as well as we might not like. Certainly earlier in the bloom, it's not really hitting those sites in a way that gives us the alerts we might want. The animals are kind of this sentinel. They come in, they tell us that something is happening. And so in a couple of these instances, we've been able to have some opportunistic sampling offshore. And you're seeing a beautiful image in the lower right here of the causative organism. This is the Seriata size class of Pseudonychia. It's a diatom. It's these long chains. And there's a lot of it offshore, at least when this sample was collected, and likely in the subsurface where a lot of this happens. And I do just want to also point out, some of you may have seen reports of a fin whale that washed up in Los Angeles. Samples for that organism have gone to Northwest Fisheries for domoic acid analysis. And we're also getting some of the more preliminary results on the toxin analyses from California sea lion tissues. And we're seeing very, very high concentrations of domoic acid. They're having to dilute those samples and rerun them on ELISA. So now what SCCOOS and CeNCOOS do is we monitor weekly at shore stations. We call that HabMap. So we do have a certain view of the rise and fall of Pseudonychia in these different size classes, which is meaningful for whether those cells are producing toxin or not, or at least have the potential to produce toxin. We also have an array of imaging flow cytobots. These are robotic microscopes at many of those sites, and they're giving us a much more higher resolution picture in terms of time. So we get an hourly sample. We can really see what's happening with those Pseudonychia cells, and we use a classifier, a machine learning classifier, to tell us which cells are Pseudonychia or any other potentially harmful taxon. We also have a model that gives us this probability of domoic acid potential. What you're seeing here is a map of the probability of a domoic acid event on the left, and we've had some issues with this model. What you're seeing is an animation of the days we have for a more experimental product, because the VIIRS satellite product that we rely on to create sea harm has had a lot of outages lately, some georeferencing issues. So you're seeing a more patchy version here, but these are probabilities. Is basically you're just saying that it's kind of, there's a lot of potential for domoic acid all on the California coast. We're also hearing that this is happening further north in Oregon and Washington. So I think there's just kind of conditions are ripe for domoic acid production all along the West Coast right now. And what's interesting about these time series plots is just that the animals were coming in at a time when we weren't seeing real spikes of the organism, the causative organism Pseudonychia at the shore stations. For instance, for Cal Poly, what you're seeing is that at that pier, right when those animals started to strike is when we started to spike, when we heard first reports earlier in July from Ventura, but we really saw the uptick in animals right around the time when we were just starting to see the causative organism rise in abundance at the shore station. So that means that things were already happening offshore. And then interestingly, we really only saw the toxigenic group much later, getting into August. We've started to see that in Santa Barbara Channel with that opportunistic sample, and then also Cal Poly Pier. And this kind of repeats patterns we've seen in recent years, where we're not always catching the more toxic cells at the shore stations, right where we're sampling all the time, in time to tell the marine mammal stranding network that they may expect something. Usually the animals come in and then we're sort of chasing it after the fact. And it's a pretty stressful thing, but we're hoping to learn a lot more about Pseudonychia so that we can fix that. All right, so I'm gonna move to the next slide. We're thinking a lot about what's causing these year after year. We know they're upwelling associated. So this is, these are two different plots of Cutie and Beauty. These are indices that give us a sense of the transport of water coming up via Ekman pumping, and then also how biologically effective that water is, in the sense how much nitrate is in that water and can it stimulate a bloom. For the latitudes of interest here, pretty much 35 and south, we're seeing mostly neutral or slightly high conditions when it comes to upwelling and upwelling, biologically effective upwelling transport. Nothing crazy here, but certainly there is upwelling, and we can see that in other maps. There certainly has been talk about marine heat waves. You'll hear more of this from Henry, marine heat waves in the North Pacific. And there are some interesting outlooks from NOAA on marine heat waves moving forward. But if you hone into our region, what you'll see is just that we're just not really seeing a ton of marine heat wave activity here. The glider time series that we have at SCCOOS and CeNCOOS supports this. You can see how the glider time series at, I think this one is for 50 meters, yep, at line 90 off of Dana Point, correlates nicely with what's happening at the equator. And we see how they were in sync during the El Nino event, and how they've both been cooling relatively from the El Nino and going to this kind of ENSO neutral condition, maybe moving into La Nina, as you heard from Dan earlier. And we can look at cross sections of those same glider time series. This one is from Point Conception, where we would expect more upwelling at this time of year. We certainly expect July and August to be a little stronger in terms of upwelling than Santa Barbara Channel and further into the Bight. You can see at 50 meters, which is a pretty good proxy for how cold and upwelling, at least the upwelling related the waters are that are coming to the surface. And this is sort of a classic coastal upwelling scenario, where you can see that uplift of cold waters right up against the coast, particularly in early and the end of July here. And you can see the same thing on line 90 further south at Dana Point. Not as intense. Those anomalies are a little bit lower in our neck of the woods, July 9th and 29th. And this maybe explains what's happening with the animals. We certainly see the preponderance of strandings in the Central Coast, where upwelling is probably stronger. You could see that in the Cutie and Beauty indices as well. And that some of the animals that we have coming in the Southern California Bight may very well be getting those toxins further north and then swimming into more local waters down here. And our shore stations really illustrate the same thing. I've plotted out where the domoic acid event occurs here relative to these temperature anomalies. Most of the time when this bloom was either initiating or developing, those waters were pretty cold in places like Stearns Wharf, where we know this bloom has been focused. We're starting to see some warming at many of these stations further south going into August. that's normal. That's certainly climatologically expected. And I've given you a little snapshot of some of the imaging flow cytobot imagery from that time period, meaning I think yesterday I took these from. And at all of those sites, we're really not seeing any of the causative organism for the bloom. We're seeing a large dinoflagellate event at Stearns Wharf as of the 13th, before that instrument went out for maintenance. We're seeing a big diatom bloom at Newport Beach Pier, despite the fact that the temperatures are going up. We're seeing something that's more classically associated with upwelling and colder temperatures. And at Scripps Pier, we're seeing mostly kind of a combination of dinoflagellates, few diatoms, and then much tinier cells offshore at Del Mar mooring. So interesting things, you know, we have a lot of eyes on the ocean, but we don't always catch the thing that's causing something that's absolutely so impactful to our environment when we see all these animals coming in sick on the beach. Okay, I think the next slide, I'm passing it. Oh no, right before I pass it to Jim, I just wanted to point out that if we look at oxygen and pH at some of these sites where we have these sensors, generally things are right on track on the mean for pH. For oxygen, they've been going down, certainly below the mean in recent weeks, and that may very well be because we have had a lot of biomass in the surface water due to this bloom, and as that degrades, oxygen is expected to come down. We may just be seeing the termination of that bloom. Okay, now I'll pass it to Jim. Thanks. I don't know.
Thanks, Clarissa. I think
Yeah, we can hear you now.
I'm coming through now. Okay, great. I'm just going to go ahead and ask a dumb question if I can. The oarfish, was that a victim of harmful algae, or are you privy to that?
I haven't heard that it is, because those are such deep organisms. I expect its demise was due to something else, and I don't think they've sent any tissue for it either in for domoic acid analysis.
Okay, couldn't help but wonder. The CDIP update, we've been seeing typical summer waves up and down the West Coast, a little bit of activity sort of in Northern California region. And we've had, unfortunately, the Mendocino buoy down for a little while, in part because of some wave activity and brief periods of time when we couldn't operate on the boat out there. Let's see, the Torrey Pines down there in Southern California is also registering typical summertime stuff. Taking a look at new stations over in the Monterey region, we have Aptos Creek, funded by California State Parks, that was installed just a few weeks ago in nearshore region. And we've got two stations going side by side, testing some ideas about the wave dynamics along the coast there. And then CDIP 156 will be re-instrumented soon, adding local seas information for all these other stations nearby. The next slide. Am I able to control this, or is somebody else driving? Thanks. Sea surface temperatures, we've been seeing them jump all over the place related to the upwelling activity. And Point Reyes, this is one of our longest standing stations. You can see that things have been wildly swinging from one extreme to the other in the July timeframe in particular. And so, yeah, lots of variation there. All up and down the coast in particular, we've seen record lows with the upwellings. And so that's the report from CDIP, and I'll hand it off to, I believe, Henry next. Thanks.
Thanks, Clarissa and Jim. Henry, let me pass this over to you. Okay. All right.
Looking for the prompt here.
Clarissa, are you still showing your screen by chance?
It says waiting to view Clarissa's screen. Top of the.
I stopped showing it.
Okay, let me.
There's a little button that says stop showing screen.
I hit that a while ago, so I don't know
Okay.
what's going on. It's stuck in purgatory.
Let's see here. Are you able by chance to switch over to Henry? Can you try that? Do you have that option?
Let me try. So I'm gonna make Henry the presenter. Is that what I want to do? Let's try that.
Yeah, like a big change presenter button.
Yep, make presenter.
Okay,
Okay, there we go.
should be working. Great teamwork.
All right. How's that coming through?
Looks good.
Okay. Okay, so yeah, thanks for the opportunity to update on what's happening in the Central and Northern California region. There we go. Okay, so yeah, so just in the past month or so, a annual, I believe, report was issued from Heal the Bay. So this is a beach report card, and it describes results from beach testing, water quality testing along the coast and beaches. And it's really focused on bacteria, and including E. coli and other harmful bacteria. And you can see on the left side, these tables, so the top set of tables is for the last reporting period, and then the bottom one is a 5-year average to reference recent variations. And you can see it's also divided into the summer dry, winter dry, and then wet weather, because we appreciate that the wet weather can be associated with extra runoff, and of course different sort of biological growing conditions in the summer and the winter, with temperature being a main limiter of metabolism. And so this past reporting period was a bit lower than the longer term average. So just at 89% for grades A and B for the summer dry. That's when many of us want to be going to the beach, but we know also that there's lots of surfers and others that do get in the water in the winter. And so those numbers, when those tests are often not passing, is important information. And you can see on the right side this beach bummer figure, which in the CeNCOOS region has a couple of stations, one inside San Francisco Bay and one just outside on the north end of the peninsula there, where we start to get into higher population areas not doing well. We also see some further south, and you know, those are larger population centers, and there's also the influence from pollution from Tijuana coming into those readings. And one of the main purposes and useful of this is that the information can drive decision making and new observations and so on. And SCCOOS has been very active in supporting some of that in the Southern California area, and also point out that the Southern California score for the A and B categories of summer dry has been is higher actually than the Central California score at the moment. So it depends on how you look at it and how these scores can come through. Okay, so a developing story in a sense. Clarissa's introduced some of the ongoing harmful algal bloom issues we have along the coast here. So the California Department of Public Health has issued a series of advisories for not commercial, but sport harvested shellfish, including 6 counties in our region. And this is expected to last through October approximately, with this sort of the cessation of HAB events as we typically see them. And so this has been in relation to toxins being found in samples taken in these counties. And so there's a precautionary approach here in these sport harvested shellfish closures. And so, you know, as Clarissa also mentioned, we have several monitoring activities that contribute to understanding harmful algal blooms and along the coast. And so we have here the imaging flow cytobot data that was mentioned, underwater microscope, and there's a network that Clarissa's helped champion along with others throughout the state and indeed other partners in the country. And so what we're seeing here is machine classified data just from through today, actually. And this is for a location in the center of Monterey Bay. And so you can see some of the images that it generates in the top left panel there, as well as the location in Monterey Bay. And on the right panel, the really colorful display, you'll see going back to the 14th of August, the sort of community composition over time. And you can see that there's these the very top of the sort of variation there is the rarer taxa, and some of those are harmful algal blooms. And if you go to the bottom left, you can see since that time, the 14th through to present, the harmful algal bloom species pulled out a bit. And one that we're watching right now is Alexandrium. So this can cause pyrolytic shellfish poisoning, and just even in the last day, it's been peaking. So not becoming dominant, so still, you know, a rare or at least less common taxa amongst all of the phytoplankton being observed, but it is notably at the pier last week. So Santa Cruz Wharf is just on the other side of this Monterey Bay, was the highest observations ever observed at that station from physical accounts. And so the HabMap program, which was also mentioned previously, contributes physical sampled specimens and sorting data. And so it's been none observed in Bodega, highest ever in the time series going back to 2011 for Alexandrium, and that's what you see there in that graph. And then it's also been found at the Monterey Wharf, which is the other south side of Monterey Bay, present, but not necessarily becoming particularly abundant yet. So something we're watching, is a developing kind of story here. And then we get into some content that's a bit like what we've been hearing about, is the sort of transition out of El Nino into La Nina looking advisory, I guess is the right category here. And so, but we can see that there are cooler periods coming into this time series. These time series are shown for the last 180 days. So on the left side, you'll see February 21st all the way through to yesterday as we go from left to right. And going from top to bottom here, we have offshore Eureka to the Monterey Bay, and you'll see that that's instead of an anomaly plot, it's a plot of the temperature versus depth, so down to 300 meters. And so you can see some of the stratification changes over time, partly in relation to upwelling there, particularly around the May-June time, and the Santa Maria buoy as well. Let's see here. There we go. And so here we have another set of stations. These are a bit closer to shore. So the Trinidad Pier, also showing similar patterns, really mixed conditions in the San Francisco estuary. And then the Moss Landing Marine Lab seawater intake. So the as arrows are not actually in the right location, but Moss Landing seawater intake is in Monterey Bay, and particularly showing cooling conditions there. So underwater gliders, so you saw some glider data in the previous presentation. Here we have some glider data from the Monterey Bay glider line, and you can sort of see how the glider data is oriented with the coast on the right side of these displays. And those are about every 2 weeks, those ocean sections. And here are these sections. So the top row is the temperature and the bottom row is the anomaly of temperature based on a reference period of about, I believe, 6 years. And you can see as we go from, these are actually going from May to June to July. You can see that the sort of isoclines there, that the black lines in the plot, particularly in the top plot, you can see them come closer up to the coast and up to the surface at the coast. And that is, again, just sort of a generic feature of upwelling indications, as well as the cooler anomalies that you see along the coast in the bottom row. Here's another way to visualize data. So this is going back all the way to 2007, so the whole record that we've got. And you can see, as is often mentioned, the warm period between 2015 through 2019, and then the current period in the very top of that panel on the right side, showing anomaly of temperature. And then you can see here is a time series for the 50 meters depth horizon that Clarissa mentioned, here referenced as well, from shore out to 200 kilometers. And that you can see in the most recent part of that we've had a return to towards nominal conditions, both in temperature and the Nino index. So here's similar plots from the Trinidad headline and the Point Arena line. that we've been running. These have not been running as long, and so the reference periods aren't really as adequate yet, but that we still are starting to plot these to help show the story about how things are changing, and things are looking fairly nominal on the most recent time period. So the heat wave indicators, so we've frequently mentioned these, and on the left side, you'll see the blob tracker that's put together by Andrew Leasing and others at NOAA. And the two on the furthest left are from the last reporting period that we when we met in June. Middle column is the figures from just the most recent plots available, and you can see that the warm area is expanded, and you can see that in previous plots in the previous presentation, and probably also coming up. And what we see there, though, is most of that is away from the coast, so not necessarily right at the coast, except for perhaps approaching the coast right at the border between Oregon and California. And in the right side, we have a gridded model that also has a heat wave classifier on it that is very similar to the marineheatwave.org indicator. And again, looking fairly benign. Upwelling, so we've seen a little bit of upwelling data so far, so that the upwelling so far earlier this season has been really focused around the tense part anyway, around Cape Blanco and down south to Cape Mendocino. And it is just becoming more nominal now. And here we have a climate indicator that goes back quite a long time, and you can see that this often sort of affiliates with ENSO or ENSO-like conditions in terms of its modularity, but it's has a bunch of different variables that go into it, including observation stations, buoys, and upwelling indicators. And you can see here that this is the Northern California one, and it's now in the nominal range, as well as the Central California indicator. And with that, I think that's CeNCOOS.
All right, thank you, Henry. And we'll move up the coast to the northwest to Jan. Henry, if you can stop sharing, and I'll try to pass it to Jan. Might be doing the same thing. If you're able to pass it, maybe you can give that a try.
Okay, I think I'm fully stopped there.
I think you have to change the presenter, Henry. The button all the way to the right.
Yeah. Go.
All right. Show my screen. Okay. Sweet. All right. So now if I do this, do you see the slides?
Yep, that looks good.
Great. Good. Oop. Uh-oh. Where'd they go? Do you see the slides, or do you see me?
I still see the slides.
Slides. Okay, great. All right. We'll have to be quick here. So welcome to the Pacific Northwest. All right, so looking at, these are sea surface temperature anomalies that NANOOS puts together based on the satellite information from NCEI. Here's what we see in terms of excess heat over climatology. You can see the period there to the left in May, in June, and then in July. And we're seeing some really intense heat in the central Pacific. In the north, you notice there's a strip of blue right against the coast for Washington and Oregon, and warmer temperatures warmer than average temperatures offshore. But is it a marine heat wave? We're going with this rendition of the International Working Group, and so on marine heat waves using Alastair Hobday's algorithm based on both intensity and duration. And so as the little indicator there shows, we've got about 300 miles or 500 kilometers offshore So there is a lot of heat out there, but it is not near our coast. So here is how the OSU MODIS analysis of the satellite data looks. You can see for May, June, and July. And it's mixed results, with it being a little moderate in May, but these, of course, are monthly averages, so hard to infer what that means to an organism, but some cooler waters up against the coast. So if we look at a NDBC buoy that's farther offshore, 300 nautical miles, we do see it reaching the 2-degree standard deviation above the long-term average based on 45 years. And so that's a bit extreme. But when we come in and look at similar mix of CDIP and NDBC buoys nearer the coast, you see there's a lot of variability, and that's typical of coastal dynamics. But we do see some excursions getting up to that 2 standard deviation above metric. And so there we go. All right. Main thing I want to talk about is hypoxia watch. And so there's too much detail on this slide. I'm going to break it through, but there is widespread hypoxia along our coast and in the estuaries. And so here's how we're observing that through several NANOOS assets. The first one is the University of Washington live ocean model that Parker McCready runs. This is, of course, a forecast model, but you're able to visualize the bottom layer as well as many other depths, including the surface. And the dark purple is the hypoxia. We also have gliders in the water. I'm just showing one that OSU Jack Barth operates in collaboration with the Columbia River Intertidal Fish Commission. And you can see that that purple down near the bottom is hypoxia off of Grays Harbor. And you can see the model has pockets all along Washington and Oregon. The Quileute tribe has made, in collaboration with the University of Washington, some landers designed to monitor currents and oxygen, and both of those are severely hypoxic at this point in time. You can see the data on the bottom. It was high around 3 or so, and then it just nosedived down to much lower levels. Here is off the Columbia River, another partner. This is CritFix Columbia River plume monitoring, and you can see the various depths, but you see 1.1 mgs per liter towards the sea bottom. So it's hypoxic there. And then in Puget Sound, we have several profiling buoys. These are showing different areas of Puget Sound, and you can see the hypoxia at Hoodsport, which is in Hood Canal. And if we blow up that picture and add one more buoy at Tuano, that purple color is the hypoxia horizon of 2 mgs per liter is the white line, and below that is hypoxic. So we have sent alerts to tribes and state resource agencies about this. There have not been any fish kills yet, but we're certainly monitoring this. All right, keeping the pace up here, we're going to switch now, thinking about temperature and salinity with these profiling buoys. I wanted to emphasize that for the last several years, this is a 14-year climatology, which isn't that long, but it's pretty good for this profiling buoy. And they tend to just be red. Even though the coast is doing different dynamics, within Hood Canal tends to be warmer than average and saltier than average consistently. So we are definitely seeing the effects, we think, of climate change driven, hydrology and temperature patterns. And certainly that's consistent with seeing the heat that Dan talked to us about. Wrapping up here and looking at chlorophyll, phytoplankton, again, these are monthly averages, maybe not so meaningful, but you do see less than average chlorophyll, and I'm only focusing on Washington, Oregon. Primarily you see blue, yet we are seeing in our harmful algal bloom bulletin the shoreside sampling that the tribes in the state do, the thing that you really need to pay attention to is that red dot with the X through it. And that is that the HAB risk is high. And so I think it's really important that people recognize when I'm talking to the media, it's chlorophyll and HAB risk is not the same. And Clarissa's sea harm is so good at giving people an understanding of that. But certainly that's salient for observing systems. So with that, I will summarize. We are ENSO neutral, but there is a marine heat wave in the North Pacific. It's well offshore. Offshore, we do see that buoy with 2 standard deviations above average temperature, but inshore it's variable, though it tends to be warmer than average more often than cooler than average. We are definitely concerned and following the coast-wide hypoxia along Washington and Oregon and in major estuaries like Hood Canal and the Columbia Plume. The Puget Sound temperature anomalies continue to be warm and salty, and satellite with lower than average color, ocean color, but persistent pseudonacia blooms through the summer on Oregon and Washington coast. With that, I will close us out and throw it back if there's time for any questions. And let's see, let me stop showing screen and change presenter back to Dan and stop my webcam.
Yeah, thank you all. Thank you, Jan, and to the other IUS presenters for the fantastic updates as usual. We are bumping up right against 1 minute to the top of the hour. I don't see any questions right now in the questions box or chat. Anyone have a question they would like to ask any of the presenters? Please type that in quickly or chime in. While people are thinking or maybe have a question, I did want to have one announcement that, so as of right now, there will be no September West Watch, but we are still planning the October West Watch with the conditions updates, and we are working out how the West Watch will move forward until someone is hired in to Joe's old position, but please stay tuned at the very least for the October edition of the West Watch. Anything from the audience or from any of the speakers before we close out for the day? Quiet group today. So, okay, well, thank you all very much for joining today and look forward to having everyone join again in October. Have a good afternoon.